This is AI Podcast. I'm David Chen, and today we're unpacking a new large language model paper that a lot of practitioners have been talking about, GLM 4.5. With me is our listener and co-host, Maya Patel.
Hi, David. I've been looking forward to this. Give me the bottom line first. What's the takeaway?
TLDR, GLM 4.5 is a single system that tries to do three things well at once: act like an agent that uses tools, reason through hard problems, and write or fix code. It uses a sparse mixture of experts' architecture and a post-training recipe that first trains separate specialists and then distills them back into one model. In practice, that means it can switch between a quick, direct mode for easy prompts and a slower, let me think this through mode for tougher tasks. Reported results are competitive on math and coding benchmarks and solid on agent simulations.
So it's not just another chatbot. It's trying to be a capable tool-using problem solver. Got it. Who's behind it?
The work comes from Zhepu AI, also known as Z.AI, with academic collaborators. Representative authors include Minli Huang and Jie Tang from Tsinghua University and Hongning Wang from the University of Virginia. It's a large multi-institution team, but those names give you a sense of the leadership.
Thanks. Before we get into the weeds, what's the background here? Why do we need yet another model?
Two trends. First, scale. Frontier models are getting huge, but instead of turning on every parameter for every token, a sparse mixture of experts routes each token to a few specialized experts. You keep total capacity high without making every step impossibly expensive. Second, reasoning. Over the past year, we've seen models improve by explicitly training them to think step by step and to use tools like search, code execution, or APIs. The catch is many systems spike in one area, great at math, or great at coding, or decent agents, but don't do all three consistently.
So the gap is breadth. We've had specialists, but not a strong generalist that can reason, code, and operate tools in one package.
Exactly. GLM 4.5 is pitched as an ARC model, agentic, reasoning, and coding, rather than a single-lane specialist.
What wasn't working in the earlier research that this paper tries to improve?
A few things. Mixture of experts is powerful, but training can be finicky. If the router sends too much traffic to the same experts, you get instability and wasted capacity. On the reasoning side, reinforcement learning can make a model very good on a narrow set of math or logic tasks. But sometimes those gains don't carry over to realistic tool use. And for agents, evaluation itself is messy. Simulated users, toolkits, and scoring choices can move the needle quite a bit, which makes it hard to compare results across papers.
That rings true. I've seen agent demos that look great, and then the same system stumbles in a different harness. So how do the authors approach this?
Architecturally, they double down on sparse mixture of experts but focus on stability and depth. Think more layers rather than just making layers wider, plus routing and normalization tweaks to keep the experts balanced. They also include a multi-token prediction component so the model can draft a few tokens ahead and then verify them, which can speed up decoding when possible.
And the training recipe?
It's a multi-stage pipeline. First, a long pre-training phase on general data with extra emphasis on code and reasoning so the base model has the right priors. Then supervise fine-tuning on curated tasks, including tool use scenarios. After that, reinforcement learning to train separate specialists, one oriented toward reasoning, another toward agent behaviors like browsing or coding in a constrained environment. Finally, they distill those experts back into a single generalist. The intuition is to let specialists push the ceiling in their domains, then teach the generalist to internalize those skills without becoming brittle.
I like that framing. Train the virtuosos, then teach the orchestra. You mentioned 2 inference modes. How does that work for real users?
In fast mode, it answers directly, good for lookups, short questions, or obvious code edits. In thinking mode, it slows down and lays out its steps. That can include explicit tool calls, like spinning up a search, running a code snippet, or browsing documentation. The user or an application layer can choose the mode, or the system can switch based on uncertainty.
Let's talk experiments. What did they actually test?
3 clusters. For reasoning, they use math and science sets that reward careful step-by-step solutions. For coding, they include realistic software engineering tasks where the model has to read a repository, apply a fix, and pass tests. For agentic behavior, they run simulated user sessions where the model must plan, call tools, and deliver a result with minimal back and forth. Some setups also allow web browsing or a terminal.
And how do they compare the model to others?
Standard practice: same prompts, similar decoding settings, and, where possible, multiple samples averaged to reduce randomness. For agent tasks, they use fixed toolkits and caps on the number of steps the model can take. For coding, they cap iterations and enforce test-based pass or fail. For math, they track exact answers and sometimes use a judge model for free-form responses, though they acknowledge that automated judges can add a bit of noise.
All right, results. Without drowning us in numbers, where does GLM 4.5 land?
In their reporting, it sits near the top on a mix of math and science reasoning, posts strong numbers on the coding side, and performs well on agent simulations. The headline isn't that it's number one everywhere, it's that it avoids being lopsided. It's consistently strong across the three lanes, with the thinking versus fast response modes giving it another practical lever.
So the story is balance and versatility. You won't always win a single leaderboard, but you can ship one model that's competent across use cases.
That's the pitch.
Give me the author's interpretation. Why do they think it works?
They argue that sparse mixture of experts gives you the capacity to house different skills without paying the full compute cost each time, while the specialists then distill strategy, transfers the edge cases learned by focused experts into a single, usable model. The two-mode inference then lets applications trade off speed and depth on demand.
Let me push a bit. Any concerns?
Several. First, evaluation comparability. Agent results are sensitive to the exact simulator and tool wiring. Even minor changes like what the search tool returns or how strict the grader is can move scores. Second, reproducibility. The team releases weights and tooling, which is great, but fully reproducing the training pipeline, especially the reinforcement learning phases and the data sets for agent rollouts, is still resource intensive. Third, mixture of experts trade-offs. You gain efficiency at scale, but you add routing complexity and more moving parts that can bottleneck on network or memory bandwidth. Finally, the use of judge models in scoring some free-form tasks is pragmatic, but not perfect. Different judges can disagree.
That's fair. If I'm a practitioner, what should I watch for before adopting it?
Two things. One, tests under your exact conditions, your tools, your repos, your data. Don't assume leaderboard gains translate one-to-one. Two, treat the thinking mode as a budget. It's powerful, but it costs more tokens and time. So set clear policies for when to allow it and how much reasoning to permit.
Speaking of adoption, do they talk about deployment details?
Yes, at a high level. The model supports long context and can take advantage of faster inference tricks. There's also a smaller variant, sometimes called an Air version, that keeps the same design ideas but with a lighter compute footprint. The usual advice applies. Choose precision settings that fit your hardware, and remember that the longest contexts and heavier modes often need multiple high-end GPUs.
Makes sense. Let's zoom back out. Can we recast the whole paper in plain English for someone who only half listened while commuting?
Sure. GLM 4.5 is a big, modular brain with many specialists inside. During training, the team first teaches a few of those specialists to excel at specific things like careful reasoning or tool-using behavior. Then they teach the general brain to absorb those skills, so you end up with one model that can both think slowly and carefully when needed and answer fast when it's easy. In tests, it looks strong across math, coding, and agent tasks, not just one of them. The trade-offs are cost, complexity, and the fact that agent evaluations aren't perfectly standardized yet.
That's clear. What about future directions? Where should the community push next?
3 areas. First, better shared agent evaluations with fixed simulators, public grading scripts, and human spot checks. Second, ablation studies to tease apart the contributions of deeper versus wider mixture of experts, routing choices, specialist to generalist distillation, in the return of more reinforcement learning data. Third, robustness testing on unseen tools, unusual code bases, and multi-day tasks that require memory and follow-ups.
I'd add deployment playbooks. Teams want reference settings, cost estimates, and recipes for running the small variant in production without losing too much quality.
Totally. Clear guidance on context sizes, batch strategies, and when to flip into the slower thinking mode would help teams control bills while keeping quality high.
Before we wrap, can you do a quick recap of the author side one more time so listeners can anchor it?
Led by GLM-4.5 with collaborators from academia. Representative authors include Minli Huang and Jia Tang at Tsinghua University and Hongning Wang at the University of Virginia. The contribution is both architectural and procedural. A stable, sparse mixture of experts design, a specialist then distill post-training strategy, and evaluations across reasoning, coding, and agent tasks.
Perfect. Final thought?
If you're evaluating frontier models for real-world software and research workflows, GLM 4.5 is worth a close look because it leans into breadth, tool use, reasoning, and coding without becoming a one-trick pony. Just make sure you validate under your constraints and set clear policies for when deep thinking is allowed.
That's a great place to leave it. This has been AI Podcast. I'm Maya Patel.
And I'm David Chen. Thanks for listening, and we'll see you next time.